talk a little about the various interview stages that are there, right? As far as the interview stages are concerned, I think in general, there are three major, or rather, when I say there are three stages, I don't mean you will have 3 rounds. 3 stages are 3 types of rounds. Think of it that way. 3 phases of your interview. The first phase is, of course, you're going to have a 0th phase, which is your resume filtering. Your resume will get filtered even before you called for an interview or anything, right? So the 0th phase is where your resume filtering happens, and simple way of filtering a resume is dependent on the skill sets that I mentioned early on. You're expected to have Python experience, you're expected to have Python or R experience, you're expected to know SQL, you're expected to know have some knowledge on big data, and you're expected to have some knowledge on deep learning frameworks, like let's say your TensorFlow or what's the other one, PyTorch or Keras or any of these. So if you've been able to tick boxes of the 4, that means you have at least qualified from a tool stack standpoint. You have qualified. So at least those are a few areas which help us filter out a particular piece of information, of a particular piece of profile. Many profiles help me filter down the profiles based on those skill sets. That's the first one. Secondly, most of the data science roles are often done by referrals. So find people who are working in a particular organization, and because it's very hard to evaluate a data scientist simply by looking at the paper. So if you know someone personally, it's much easier. So try to find someone who's working in a particular organization. They can vouch for you, and they can bring you along. So that's the other thing. So once, let's say, your profile is shortlisted, and shortlisting of a profile would not just depend on putting random tool stack in your profile, but also on the work that you've done. So to evaluate what kind of work that you've done, you would have a hands-on session. Right, a hands-on session essentially is a session that is generally conducted to ensure that you have those skills that you claim that you have. Right. For example, if you claim that you're very good with Python, then you better prove it. So platforms like Codility, HackerEarth, and there are many tools right, that are available. Codebase, things like that. So there are so many tools that are available, so many online platforms that are available that help us conduct online that give you online challenges, and you're expected to solve those problems. Right? These problems can be of 2 types again. Right? These challenges could be generally of 2 types. These hands-on sessions could be of 2 types. One is, let's say, an on-site challenge. That means you're given, let's say, 3 to 8 hours, and you're expected to sit down there and solve the problem then and there, right in front of them. That's one way of solving it. The other is a take-home or a particular what do you call it, or a particular project that is given to you for, let's say, a week or a few days, and then you're expected to solve that particular assignment, and then you're expected to come back and display or showcase your results. Yeah. Am I audible now, Ajay? Yeah. Okay. So both these tools are quite important. I mean, both these approaches are quite useful in displaying your Python skills. For example, I'll tell you one of the interviews that I recently attended, and one of the things that they had set up was it was an interview that essentially lasted for 8 rounds, and of course it was for a senior role, so for a senior data scientist role. Just give me a second. Is everybody able to hear me? Yes or no? Oh, cool. Okay, so thank you so much. Yeah, so there are generally 2 kinds of, as I said, the 2 types of assignments that are generally given. One is a take-home, and the other is an on-site challenge. I was given a take-home assignment in this particular interview that I recently attended. I was given, so that particular assignment lasted for 2 hours. Even in this particular assignment, I was given, and this is a general framework of how interviews are conducted. So we were generally given either a data science problem, which basically means is a data set is given to you, a problem statement is given, just like Kaggle, right? If you remember Kaggle, if you're familiar with Kaggle as a framework, just like Kaggle, you're given a data set, you're given a piece of data, and a problem statement. You're expected to go ahead and build a model and showcase your results in your and you're expected to showcase your results in, let's say, um, a Jupyter notebook, or you're expected to present these results in that particular Jupyter notebook, right? That's one kind of a test. So this test could last around, let's say, 2 hours to 8 hours, depending upon, again, problem to problem. Certain assignments, for example, in one of the very early experiences of mine, I was given an assignment which expected me to, let's say, go ahead and code a decision tree algorithm from ground up. That means I was not allowed to use any code whatsoever, any library whatsoever. I was expected to write a decision tree algorithm in pure code, in pure Python code, and yeah, I mean, I was given 1 week time, and I was expected to go ahead and solve this and come back. So there are different kinds of problem statements that are generally given. At times, these hands-on sessions could also go to the extent of giving you a coding challenge. Like, for example, you're given a small algorithm, and you're expected to write that algorithm. Right? Let's say top coder, or let's say code chef. These are tools that generally test you on your algorithmic and data structure skills. These tests could also go in that direction. So expect a hands-on session. That's generally the name of the game these days. Most companies have a hands-on session these days. Without a hands-on session, irrespective of the experience you have, people are not hiring without a hands-on session. It will definitely apply to freshers. Yes, freshers. The one thing that people expect from freshers is coding skills. So if you are, and one of the reasons why people hire freshers is because you are good with your is because you're good with your coding skills. So definitely a hands-on session is conducted for freshers, not only for experienced people, even for freshers, the hands-on sessions are conducted. So get ready for it. Get ready to experience that. That's the first thing. It is a very good place to showcase your skills, right? So go the extra mile, do whatever you can to do whatever. I mean, make sure that you display as much variety as possible in your skill set to solve solve problems during this particular thing. Also, at times, expect SQL based questions as well, right? SQL based questions, meaning you will be given a virtual platform where you're expected to write some SQL from some SQL queries. They'll give you some 2 tables, and you're expected to solve that particular problem using those SQL queries. Write some SQL queries to either, let's say, merge data or do things like that. Join data, or perform some kind of transformations on top of data and things like that. Right. So that's as far as the hands-on session is concerned, hands-on round is concerned, and this is evaluated. Remember, this is not evaluated by the HR. This is evaluated by a data scientist. So a data scientist is going to sit there, and he's going to look at these results, and he's going to come back and tell you if you're selected or not based on this particular hands-on session. So understand that. Try to give your best in your hands-on session, because this is a make or a break. If you don't clear the hands-on session, then there's no way you're going through. So make sure you write comments very well. You have to add as many comments as you can, and give enough explanation about why you've done a particular step. Don't just randomly put code, in the Jupyter notebook. Make sure you add enough comments, or enough doc strings that you leave within the functions that you write, and things like that. Okay, that's as far as the hands-on session is concerned. Once you clear the hands-on session, right? If you've cleared the hands-on session, then pat yourself on the back. That means you've done a good job, right? So, but before you even enjoy your you clearing the hands-on session, you will have a lineup of technical interviews. Now, the technical interviews could be done generally. Now, in my organization, we have two to three technical interviews. Depends from company to company again. So, for example, Amazon would have 3 to 4 technical rounds of interviews. Microsoft has 2 to 3 different interviews. So we have 2 to 3 technical interviews depending upon the candidate again. So the first interview could be a simpler round where one of the team members or senior team members could be interviewing you. And it is going to be a data scientist whole interview. So they're going to be hardcore technical questions. And I'll talk about how and what kind of questions are going to be asked to you in the next section. When I talk about the questions, I'll ask you about them there. I'll tell you about the kind of questions that you're likely to be asked as we move forward. The next round is also generally by a technical person. It could be a data science team manager. I was interviewed by data science team managers from various different locations. So I was interviewing for a particular location. I had different data science managers coming in from different locations to interview me. I was, let's say you also let's say you clear these rounds as well, then the next round is generally by the org lead, the head of that particular organization, vice president. The interviews that are generally conducted by the product owners, or let's say principals, partners, or delivery heads, or vice presidents, they are very, very business oriented, right? These are not technical rounds. These are non-technical rounds, but based on data science, where they are going to test you on um, they're going to test you on your business acumen. How well do you understand businesses? How well can you translate a business problem into a data science problem? Again, these rounds will depend on the role that you're applying for. So let's say, for example, you're applying for a consulting role, then you would be interviewed by, let's say, a partner or a principal, or let's say a practice lead for that matter. If you're interviewing for, let's say, a product division, product company, then you would be interviewed by a technical manager and, let's say, a product sponsor or a product owner, because they want to make sure that you have enough capability to solve that particular problem. Again, the depth of interviews may depend from one company to another company, but essentially get ready for at least 4 to 5 rounds of interviews on an average. I'm talking about on average in a fairly reputed industry, MNC, gear up for 4 to 5 different rounds of interviews. At this particular point, what we are seeing is, of course, more or less all the companies do have a ban on hiring given the COVID situation. But in general, what we generally see is we prefer conducting these sessions face to face as much as we can. If not possible, of course, we do some preliminary rounds in telephonic, and then so R1 can be conducted. The first technical round may be conducted as a telephonic round, but eventually the person is called upon because you'd want to have a face-to-face interview. So face-to-face is generally preferred, at least for the later parts of interviews. Face-to-face interviews are generally preferred. So that's generally the layout of how your interviews would be conducted. Expect a hands-on session, expect a couple of, expect at least 2 or 3 technical rounds, and expect one hiring manager or a lead, a vertical head or a vertical lead delivery head, sort of a person who will be taking your interview. So yeah, I mean, for example, Amazon by default has around 8 rounds of interview with respect to the role that you're attending. But in general, data science, yeah, you're looking at around 4 to 5 different rounds. I applied for a strategy consulting company a few years ago, and I had 8 rounds of interview there as well. So there was different people who were being called upon, different people who were asking me questions. But I think it's good in a way because it gets to the flavor of what they want from you and things like that. So yeah, that's essentially the layout of how your interview generally looks like. But I think the more important question is, what kind of questions do these guys ask, right? In a technical round, what kind of questions are generally being thrown at you, would be thrown at you. So in a technical round, the type of questions that are generally asked is, again, I could probably break this down into 3 different categories. I don't know, 3 seems to be the number of the day, but 3 broad categories. The first one, of course, is questions based on any previous experience that you have. See, as a data scientist, because all of you are fresh in the industry, it's unlikely that you would have, because all of you are moving into the industry for the first time. As a data scientist, as an interviewer, I would be searching for some common grounds to ask a question at you, right? If you simply come and put your past experience and tell me that I've done a course in data science and I'd like to move into the field of data science, it's unlikely you will get hired. I mean, it's unlikely that you will find people who will be interested in you. So you have to find some common grounds between yourself and the interviewer. And the way you could do that is by putting some kind of data science experience in place. What kind of experience do you put in? Let's say you've solved a Kaggle problem. That's also some kind of data science work experience. Of course, it's not quote unquote official work experience, but it is definitely some work that you've done in the field of data science. So it gives the opportunity for your interviewer to ask you questions on. That's the first thing. Secondly, if let's say you've done any project in your course, you've done a course, let's say you've done some capstone projects, so let's say you've done any kind of projects in your course, or you've done a side project, that could come in handy as well. So Kaggle projects, or let's say some capstone projects that you've done in your class, within your course, or let's say any kind of data science solutions that you, let's say, were a part of in your previous organization, but you of course were not actually doing the data science, but let's say you're a part of a data science team, and if you could quote some data science work that you could have possibly done in your previous organization in the data science team, then that could come in very handy, because that could prove very useful to in terms of at least establishing some common ground between yourself and the interviewer. You don't want to randomly put something. So let's say you solved a Kaggle problem, right? That gives some scope for the interviewer to ask questions on. Okay, so if they see that, okay, you solved a couple of Kaggle problems, mind you, people like Kaggle problems, right? Trust me. Most people prefer people having some kind of experience. It's not that you would randomly. It's not that you'd want to have some experience before you actually attend an interview. And Kaggle problems, people do recognize that as valid experience. So let's say you solve a particular Kaggle problem. What kind of questions can you expect from those? You will be asked about what kind of steps did you perform, what kind of, let's say, what was the problem statement about, why are you solving that particular problem, what is the business impact of solving that particular problem, and you will have questions about what kind of pre-processing did you do, what kind of model did you build, how did you evaluate your model, why did you only evaluate your model in that particular fashion, why could you not have used another kind of evaluation technique, and things like that. So there could be other questions. There could be a laundry list of questions that could be shot at you, but all of them could more or less be based on the work that you have previously done. So that's the first category of questions that you could be asked. The second category is pure play technical questions. Out of the blue, they might throw some question at you saying, how do you build a decision tree algorithm? Explain a decision tree algorithm ground up, right? Don't expect these questions to be completely vague. They will still be relevant to the work that you would have more or less done, but pure play technical questions, right? The third is scenario-based questions, meaning the interviewer might give you a particular scenario or case study, and he would then ask you to go ahead and design a data science solution or data science problem around this particular problem statement, and tell me how you will solve this particular problem. So you'll be given a scenario, and you're expected to sit down then and there, solve this particular problem, solution it right at that particular point in time. These would be real-time scenarios. Absolutely, yes. These could be real-time. It could be hypothetical as well. But in general, most of the questions that are generally asked are real-world scenarios. Yeah. Then that'll be tough to. Absolutely, yes. I mean, that's the whole point of an interview. So the questions, it doesn't matter if you don't answer. What we are looking for is, do you have the ability to at least to at least approach the problem in that particular direction. We don't expect you to, as an interviewer, you're not expected to be spot on with your, as a candidate, you're not expected to be spot on with your answer. You expect some guidance by the interviewer as well. They'll guide you through your solution, because even in a real world scenario, it is not one person who sits and designs a solution. It will be multiple people who will sit down and design a particular solution. So you are essentially starting the problem in a particular direction. You're expected to solve it, or rather design it in a certain way, and then we can talk about it. I'll give you an example. When I, in the next slide, I'll give you an example of what kind of problems are generally asked, what kind of case studies are generally asked. I can give you a couple of examples from the interviews that I've attended previously, or I've taken, with the kind of interviews that I have asked, the kind of case studies that I have asked in my previous interviews. I'll give you those as well. Yes. So which we have done in course absolutely, yes. Projects that you've done in the course, you can definitely mention as a capstone project, and you can use that. Yes, absolutely. Mention all the work that you've done, right? Of course, when I say mention all the work that you've done, do not mention that you've built a classification algorithm on iris dataset, right? So make sure that it is a proper problem statement, and you've done enough analysis around it. Don't just randomly put a classification problem as a project. So make sure you have spent enough time in terms of researching on that particular problem, and if you have solved that problem, if you've solved that problem holistically, then you should be happy to. It should be perfectly all right for you to add that as a part of your profile. Yeah. For technical questions, do we have to remember the built-in? No. Pradeep, good question. Very, very good question. Do you need to remember functions? Do you need to remember built-in methods? If somebody is interviewing you based on tell me a function for decision tree in R, or tell me a function for decision tree in Python, trust me, that interview is not worth attending. Because if you have reached until this particular point, you've already done your hands-on session. Which means most likely you would have solved your hands-on round. Most likely you would have cleared the hands-on session and you are sitting in this particular stage. So nobody is going to question you about functions and syntaxes. Nobody will question you that. And even in your hands-on round, generally, you will be given, generally, I'm not saying in all cases, generally, you will be given access to internet and things like that. There could be scenarios where the interviewer could be sitting right on top of your head and you're expected to code in an editor. There could be scenarios like that, but those are very few. In general, in most cases, you will be given access to internet. You'll be given a machine. It's okay for you to Google and solve problems. So it's okay. So nobody asks you questions on syntaxes in an interview. It's generally clarified through the hands-on session. So, yeah. Cool. Okay. So these are the three types of questions that you could expect. One is questions based on your previous expertise or experience, case study based questions, and pure technical questions, pure play technical questions that could be asked. Let's talk about what kind of questions do they ask, right? So here's some tricks of the trade. So I'm as an insider, I'm giving you some inside dope about what kind of questions are generally asked. Okay, as an interviewer, these are the questions that I generally ask. Always remember this one thing, that data science as a field is a vast field, is a large field. It's and all data scientists understand it, right? Data scientist as a field is so large that there are so many sub fields inside the subject of data science. Somebody becomes a computer vision analyst, or computer vision specialist, or computer vision scientist. Somebody becomes a natural language processing scientist. Somebody is a machine learning specialist who strictly works on machine learning. So they're different pieces of work that people specialize in as they move forward in their careers. So you are not expected to be a master of all. So hence, as a result, what happens is most of the data science interviews are based on the work that you have previously done, right? most of the data science interviews are based on two things: the work that you have previously done and the kind of role that you're interviewing for. What that means is, because the field of data science is so large, if I were to ask you a question, it will be unfair if I ask you a question on something that you have not worked on previously. Because if you ask the interviewer a question that he has not worked on, he will not be able to answer himself, because the field is so new, the field is so evolving, uh, the field is rapidly changing in active research. Hence, that's one of the reasons why people prefer asking questions from your previous experience. The second is, and it's a general um, and it's a general sentiment. The first two lines that I've mentioned is a general sentiment of any interviewer. Trust me on it. I've interviewed so many candidates, and I have seen so many people interviewing candidates. I've attended interviews myself, so I understand that the first two lines are absolutely true. In most cases, in 90% of the cases, there are always that 10% of category uh, who who find some kind of happiness in interviewing someone and making their life difficult. So I'm not talking about those 5-10%. I'm talking about the generic crowd. For the second type of questions will be based on the role that you're interviewing for. So let's say you're interviewing for a strategy consulting company, or let's say you're interviewing for a technical consulting company, technology consulting company, like let's say Accenture. You're interviewing for Accenture. So your questions will be the questions that you will be asked will be based on, okay, you will be working with a client. So how will you explain a linear regression model to a client, right? How will you explain the output of a logistic regression model to an end customer? Let's say you will be presenting to a vice president of a particular organization. You're working with a particular client. You'll be presenting your results to the vice president of a particular organization, to that particular client of yours. How will you explain? You've built a logistic regression model. How will you explain the coefficients of a logistic regression model to your end customer? Right. So the coefficients of a logistic regression model. How will you explain it to the to the end client? How will you explain the coefficients of a linear regression model? How will you explain a decision tree? If you were to explain, this was a question that was asked to me. If you were to explain a decision tree in layman terms to to someone who does not understand data science at all, how will you explain data science to a complete layman, to a complete layperson who doesn't know anything about data science? How will you explain it to him or her? Right? Because you will be talking data science to such people, because you're in a consulting company, you will be talking to people who don't understand data science. So you will be in situations where you will be asked to explain these complex algorithms in a very, very simple form to someone who doesn't understand data science. Or how do you explain a confusion matrix to a complete layperson? Right? So communication skills are super important, and these specific questions, these specific questions will be asked to you whenever you're talking about questions based on roles. So two categories of questions. Of course, these are different uh, different types of queries that could be asked. But I think all these queries will be filtered by your previous experience and technical questions or non-technical questions based on the role. I think it's better I mention it that way. Technical questions based on the role you've applied for. So that's how your questions can be primarily categorized into. So those 2 points that I mentioned over there are really, really important. So keep that in your mind. So don't worry if you don't know something. Say a no. You don't have to dump your profile with all the possible keywords in the world. You don't need to do that. I understand most of us do it for to make sure that our profile gets shortlisted. But I think you have to understand that it's not. Interviewers do understand that it's not possible for one guy to have an experience on every possible thing on the planet. So it's okay if you do not know. If you have not worked on NLP, you have not worked on NLP. It's okay. If you've not worked on computer vision, you've not worked on computer vision. That's okay. But at least you should know the basics of natural language processing or text processing. You should know the basics of computer vision, basics of how a simple deep learning model works on images and things like that. So you should be able to explain the basics of it. So when you talk about your previous project, let's say you've done some project, or let's say you've done some previous work, what kind of questions can you expect? Let's take the example. Let's take an example. Let's say you have solved a particular classification algorithm to predict will a particular person churn out from a telecom company or not. A very, very classic problem that any telecom company would be ideally solving, right? Predicting churn, right? That's what we call it. So let's take this example. Okay, so when you predict churn prediction, when you predict churn, let's say you've done this as one of your previous problems, or let's say you've solved this as one of your Kaggle problems, right? Kaggle also has a lot of such problems, so you can go back to Kaggle and then solve any of these problems. Let's say you're trying to predict churn. What is churn? Anyone who understands what churn is? Churn is basically the probability, or churn is that particular behavior of a customer when he or she quits a particular service provider and moves on to another service provider. So for example, you've quit AT&T and you move to Verizon, or you quit Jio and you move to Airtel. Such kind of an exercise is typically referred to as churn. It's not only in telecom, it is applicable to any competing platform, right? So for example, you are a customer of let's say a particular insurance provider. You quit that insurance provider and you're moving into another insurance provider. So that is churning of a customer. What you're trying to predict is, you're trying to predict based on the behavior of a particular customer, you're trying to predict will the customer churn out or not. A nice classification problem, right? So the questions that you can expect here are, first things first, why are you solving this problem? Why are you predicting churn? Why is predicting churn important for the business? Why is predicting churn important for the business? The reason why predicting churn is important for the business is because it helps me identify it helps me identify which customers are likely to quit. Hence, even before they actually quit, I can reach out to them and I can do some kind of intervention. I can provide some kind of intervention and stop them from quitting. So for example, if a person chooses to quit, let's say Jio and join Airtel, or quit AT&T and join Verizon, then I can, as AT&T, what I can do is I can intervene in between, and I can tell that, okay, sir, looks like you've decided to quit. Is it okay if we'd like to provide you an offer, and we'd like to retain you as a customer, and because you're one of our loyal customers, we'd like to give you an offer, and the offer is, let's say I give you a $20 discount over the next X number of months, or let's say I give you free voicemail services for the next X number of months, or let's say I give you free 1 GB internet per day for the next X number of months. So I give him some offer, right, to retain him. So predicting churn is really important because it helps me. I predict which customers are likely to quit and stop them from leaving, or try to at least stop them from leaving. Right? Intervene, provide some kind of intervention strategy. The second reason why I'd like to predict churn is because currently for a company like AT&T, the churn rate is at around 6%. 6% churn rate is very, very high, and one of the primary objectives of the organization is to increase the customer base, which means we have to make sure that the number of customers quitting should reduce. So how do we do that? By making sure we stop people from leaving, or predicting even before they could possibly leave. Right? These are two possible reasons why I might want to predict churn. Okay, one, I know that it's a big business problem, high impact business problem. Second, I know that the reason why I'd want to predict churn is because it is a part of my business charter. It's that's how my business wants to operate. So, okay, business explanation provided, and you can drill deep into it. I mean, if you know more about that particular problem, you can dig deeper into that particular problem. Great. Okay. that's the reason why you'd want to predict churn. So the next question is, how did you go ahead and prepare your data, and what kind of data was available with you? Great. So I am in a telecom company, right? So let's say I'm in a part of the telecom company. This is telecom customer, let's say. The kind of data that we had brainstormed to identify what factors could influence churn are as follows. The first one is billing reasons. The most important reason why customers quit in telecom company is because of billing. High bills, greater chances of quitting generally, right? Sudden spike, billing information was available. I know previous history about the customer, uh, customer care information, meaning how many times has the person reached out to the customer care and things like that. Some kind of demography involves age, location, and things like that. So for example, people who are 60 years old, 55 years old, the likelihood that they would quit will be very, very low, right? Because by now they're like, oh, care. I mean, it doesn't matter. If I'm spending 500 rupees a month on my telecom, it's okay. They probably reach that particular stage where they don't worry too much. But a 20-year-old or a 16-year-old who is having a mobile phone, 500 rupees a month is very, very expensive for him or her because they are not earning as yet. So the likelihood of somebody quitting is much higher in a lower age group than in a higher age group, obviously, right? So demography is really critical. In addition to this, we have also taken into account, let's say, um, the his current plan information, what kind of plan is available, some kind of competitor information, and things like that. So on and so forth. This is the kind of data that we've taken into account, right? So at this particular point, you could be asked questions saying, okay, don't you think um, the order information about or value added services that are being used by these customers are important in predicting churn? Meaning value added services are like, let's say, voicemail. Value added services could be, let's say, missed call alerts and things like that. So don't you think those are important in predicting churn? Or maybe they are. If somebody does not use a lot of value added services, they are not making the most out of the company, so they probably do not have enough loyalty towards that particular company, right? And hence they might want to quit, right? So you might also want to use information about what kind of tickets were raised in the customer care. Don't you think tickets information is important? So you could ask questions like these. What kind of data was used? This is the kind of data that was used. Okay. The next question could be, how did you prepare your data? What was the data preparation that you had to do? Great. So the way we prepared our data is we had to do some data pre-processing. For example, our demographic data had some missing values. We had some erratic data points, like for example, there were data points which had age which is greater than 100, 101, 120. So some outlier removal was done, some missing value imputation was done, some scaling was performed to a few features, some additional features or some feature engineering was performed. Feature engineering meaning some new features were extracted from my data and things like that. So that's how we prepared our data. Our data set had a few. Eventually, I created my data which had X and Y, where X had all my independent features and Y was my dependent features. Now the question could be, what was the size of the data, and why did you and how did you go about solving this particular problem? So currently, your question is, okay, let's say at this particular point I had 1 million records. My X's were 1 million, and my size of my data set was 1 million, and my X and Y put together had a size of 1 million. I split this data into two parts, which was train and test. 60 and let's say 60% and 40%, or 70% and 30%. However, I used my train set to build my model and evaluated it on my test set. Great. At this point, you might have been asked another question: why could have you also performed cross validation? Why did you not perform cross validation? Well, cross validation could have also been performed. Yeah, I mean, I probably missed out on that. Maybe we should have performed cross validation here. So, at that moment, you might be asked questions about what is cross-validation, right? How is cross-validation different from train test split? What is the benefit of using cross-validation, right? You'll be asked questions like that. You could also be asked questions on, you've performed outlier removal. Explain what an outlier is. What is an outlier, anyone? An outlier is a point that behaves erratically from the rest of the data points, right? So you would want to identify, okay, how do you identify an outlier? How do you identify a particular outlier? Anyone would want you to run a ping and say, how do you identify an outlier? Boxplot, yeah, absolutely. Boxplot is one way of identifying outlier. Boxplot is not the only way of identifying outlier. Of course, Boxplot is one way of doing it. You could also do it via, let's say, you could simply use a simple terminology of your histogram. You can plot a histogram and you could also visualize on either side. Or let's say you can look at mean plus or minus 3 standard deviations from the mean. Mean plus or minus 3 standard deviations. Any point which is less than 3 standard deviations from the mean and greater than 3 standard deviations from the mean are considered as outliers. Mean plus or minus 3 sigma, or z-score, exactly. You could use z-score to identify it. So things like that. So these are different ways of evaluating a particular, removing outliers. How do you fill missing values? Why did you fill missing values? Should you fill missing values or not? I mean, if let's say your data set has 20% of missing data, what do you do? Or if your particular column has 30% missing values, what do you do? Do you fill missing values? Let's say there's a column and the 30% of the data is missing. What do? Fill it with mean, okay? If 30% of the data is missing, would you still go ahead and fill it with mean? Think of it. Yes, okay. Interesting, okay. Yeah, so generally, when you have more than 30% of the data missing, I would think of two things. One, do I have enough data points? Do I have enough data points or enough records, enough observations in my data, enough rows in my data to remove those 30% of the rows, right? So if I remove 30% of data, let's say I have 1 million observations. If I remove 30%, it's okay. I still have 70,000 records, or let's say 700,000 records available with me. So I might, in that case, remove rows. Right? But if my data itself is very small, let's say just 20,000 observations, if I remove 30% of it, then I'm losing a significant chunk of my data. I'm losing around 6,000 records out of 20,000, which is a huge dent to my data size. So in that case, I might want to decide and say, okay, let me drop the column. Worst case, I might go ahead and fill missing values. Filling it with mean, median, mode. I might only do it in worst case scenario. I might not do it always, right? So that's probably the last approach that you'd want to follow to fill missing values, because filling missing values essentially means you are speculating on the data. That means you are filling with values that are actually not a part of the data. So you don't want to speculate too much about a given data set. So that's the reason you wouldn't want to fill too many missing values. The point that I'm trying to drive here is every statement you make, you will be double clicked at that. Meaning, if you say that I have filled missing values, you'll be asked. You could be asked what kind of imputation techniques are, do you know of? Right? How do you why should you fill it with mean? Why not with median? When do you fill with mean? When do you fill with median? The questions like these will be asked. So when you build a train test, when you build a model, then the question could be, what kind of model did you build? Did you do even before did you directly jump to model building, or did you do any kind of data visualization? Did you do any kind of exploratory analysis? So you could be asked questions like these. Let's say if you say that, okay, yes, I've done the exploratory analysis. The questions could be, what kind of exploratory analysis have you done? Okay, the kind of exploratory analysis that I've done can be categorized into two parts. One is univariate and multivariate analysis. Univariate analysis is analyzing single variable at a particular time. Analyzing multivariate analysis and analyzing multiple variables at a given time. Meaning, histograms are univariate charts. Your correlation is a multivariate analysis. Your scatter plots are multivariate analysis, and so on and so forth. So you would want to mention that I've done univariate and multivariate charts. So the question could be, what findings did you see from your univariate and bivariate chart? From my bivariate charts, that I've understood that age and churn rate are negatively dependent on each other. That means higher the age, lower the chances of somebody churning. That's something which we have recognized. Secondly, what we've also identified is higher the age and bill amount seem to be negatively correlated with each other. That's another thing that we've identified as well. And what we've also identified is churn is heavily dependent on the location. That means certain specific areas, they seem to have a high churn rate as opposed to other localities. Okay, so you essentially mentioned the insights that you've generated from your exploratory analysis step. Once you've done your exploratory analysis, the next step is, okay, now you've done your exploratory analysis, so what have you done next? We went ahead and we performed model building. So when you build, what kind of model did you build? Let's say you mentioned that I have built a random forest model. The question straight away would be, why did you not try logistic regression? Why did you go for a random forest model? So you have to be careful when you mention these. Always clearly explain the experimentation that you have done, that you have performed. So you can simply say that, okay, first I built a logistic regression model. My model was not doing great, hence I tried a random forest model. Immediately the next question would be, how do you know that your model is not performing well? Okay, to know that, so because this is a classification problem, I had to evaluate my model based on confusion matrix. Straight, the next question is, what is confusion matrix? Right? So almost every step you will be asked a question. So rehearse this story very well, right? If you're putting a particular problem statement within your analysis, within your profile, if you're saying that I've solved so and so particular problem previously, then make sure that you have a that you've done this analysis really very well. That means at every step you should be able to explain what you have done, right? At least to some level of clarity, you should be able to explain what kind of pre-processing have you done, what kind of exploratory analysis have you done, what kind of model building did you do, how did you evaluate your model, was precision important or was recall important, right? Between precision and recall, how do you differentiate between precision and recall? When is F1 score needed, right? See, for us interviewers, right, one of a simple litmus test to evaluate if a candidate is fit or not is based on your understanding around confusion matrix. If you understand confusion matrix well, then that's an indication that, okay, looks like you've been able to get a hang of things. If you haven't understood confusion matrix and if you're still claiming that you have learned data science, then I'm sorry, you probably not. Then that's a very clear indication that you could be sent back home. So if you're getting grilled on confusion matrix and if you are unable to answer questions in confusion matrix, my friends, trust me, go back and do good research on and spend some time on how confusion matrix works and understand how precision recall F1 scores are really work. Right? So that's a nice way of identifying. It's a nice hack that we interviewers apply whenever we want to identify if a candidate is really good or not. Right? So we question quite a bit about evaluation of models. So how do you, if confusion matrix is for, if you use precision and recall for classification problems, then what do you use for regression models? What metrics do you use for regression models? So the answers could be, what kind of approaches do you use for regression models? What kind of measures do you use for regression model? MAE, exactly. MAE, MSE, RMSE. Spot on. Perfect. MAPE. The different metrics that you can use over here. Yeah, spot on. So that's how your interview conversation is going to go on. Especially here at this particular point, I've just mentioned a few questions here. I think it's worth for you all to go back, have a look at the slide, and prepare your problem or your project, or prepare yourself for answering these questions around the projects that you've done previously. So if you are claiming that you've done your project well, then make sure that you have answers to at least 80% of the questions here that you see on the screen. Okay. Especially, what is the most important thing? I mean, all the sections are really important, but one of the things that people often fail to understand. So, for example, if it's a Kaggle problem, um, for a Kaggle problem, you might only know the business problem. You might not know the business impact, so to say. That means if you solve a Kaggle problem, the Kaggle on a Kaggle platform, the problem statement would simply be mentioned, but you might not know what would be the impact of solving this particular solution. That means you solved a churn prediction problem, but you wouldn't know what is the business impact of that particular problem, right? So that's one of the things that you have to keep in your mind. So it's okay. It's okay if you don't know a lot about it, but at least what you should definitely be able to talk about is what else you have done as a part of your as a part of your solution. The other thing is, if this is an open source problem, I mean, it's a problem that you've done on Kaggle or something like that, then put it up on your GitHub profile online. Use your online GitHub profile and put content there. Put a notebook or put your code that you've done and put it up there for everybody to consume. Let everybody use it. I think it's a nice. I mean, you can put a GitHub profile in your resume as well. That way, you can draw a little more eyes. You can add more credibility to the work that you have done. So while some interview is being taking place, somebody might just go to your GitHub profile and actually view what you've done in your GitHub profile. It helps. Um, it helps identify how well have you solved, yeah, or how well have you written your code. What are the most used models? See, there's nothing like that. There's nothing like what is the most used models. That question clearly tells me that you haven't been doing that you haven't been practicing well. There is nothing like a most used model. Uh, all models have a specific purpose. Like, for example, people use logistic regression if I want higher amount of explainability to my model. So let's say if you want, meaning because I have coefficients, it is easier to explain. I use logistic regression or decision tree algorithms whenever I want to explain my models to someone. But if I want high accuracy models, then I would pick, let's say, a random forest model, or let's say boosting models and SVM and slightly more complex models in such case. So every model has its own purpose. So based on the problem that you're solving, you want to pick a particular solution, pick a particular problem, pick a particular algorithm that'll work for you. I'm not saying that this model is better than the other. Everything has a purpose. Yeah. Questions on deployment. Good question. Yes. Now, I wanted to talk about that. So as far as model deployment is concerned, again, if it's a project that you have done previously in your previous company and you've helped them solve a problem, then it's worth talking about deployment and things like that. Generally, the questions of deployment are asked to people who have had prior experience in solving data science problems, or people who have solved data science previously. That means who've had IT experience firstly. I mean, people who have been with the IT industry, because you are experienced, hence you are not going to simply be asked questions around how do you solve a data science problem. Rather, they take it to the next level of saying, okay, now that you've built this model, how do you deploy the model as well? So how do you operationalize models and things like that? So read about it. For freshers, you're generally not asked questions about deployment and things like that. It's good to learn. There are concepts around Flask. There is something called as Flask, and there is something called as you could deploy a predictive model as a REST API endpoint and things like that. So for experienced people, you may be asked questions on deployment. For freshers, I think the concentration for you all will be primarily around how did you solve a problem, and primarily the first four sections, or first 5 sections more or less, than the business than the deployment itself. I'm sorry, I'm not able to answer all questions. I will answer them. but I'll try to take a few questions before I move on. Yeah, the most frequent kind of problems that are solved are supervised learning problems. Um, Reinforcement learning sounds cool, but it's not an easy technique to use. So, not a lot of problems that we solve in the modern day, and at this particular point, are um, belong to the reinforcement learning bucket. I would say 80% or rather 60%, 60 to 70% of the problems that we solve are primarily supervised learning problems. There could be a few that are, I mean, there are, of course, that 30%, 35% of the problems which are unsupervised learning. The rest 2 to 3% problems are your reinforcement learning problems. So I think if you were to, I think if you were to um, prepare yourself for a data science interview, it's worth spending your time on supervised and unsupervised learning than reinforcement learning. You spend majority of your time on supervised and unsupervised learning. Yeah. Apart from the hands-on round, all are basically from project we have done, more or less. Yeah. Apart from the hands-on round, most of the questions that you would be asked will be on the projects that you've done previously. Majority of the grilling will happen in that direction only. Um, you could also be asked questions based on scenarios. That means you would be given a particular problem statement on the fly. You're expected to solve it. I mean, solve it in the sense you're expected to answer questions on it. But apart from that, case study or scenario-based questions, majority of the questions will be based on will be based on your project-based questions only. And I'll talk about scenario-based questions in a few minutes. Okay, how to explain a person who does not know data science concepts? Yes. Okay. So let's take the example of linear regression, right? And I'll give you an example of one model, and I'd like you to look at every other model in the same fashion. Let's take the example of linear regression. A linear regression model. Let's say you've built a model which has information like this, like which says sales is equal to a linear regression equation. Let's say your problem statement is a ballpoint pen manufacturing company would like to predict the sales of that particular company in a given region, right? Predict sales of a ballpoint pen manufacturing company in a particular region. So there are many regions, and I'd like to predict what the sales of that particular what the sales will be based on that particular region. So let's say you've collected your data and then you solve your problem, and your equation looks like this. So sales is equal to 40 plus. You found your linear regression equation like this. I hope you all understand how to create this particular equation. In Python you can use your linear regression model, or in R you could use the LM function. So there are different functions that will help us build this particular equation based on historical data. So you have 40 plus, let's say 10 times money spent on ads minus, let's say 5 times number of competitors in that particular region plus I don't know what else could, so plus 6 times number of stores where we sell our pens. So my sales at this particular point is dependent in this particular, using this particular equation. Now the question is, how do I explain this to someone who does not understand linear regression? It's very simple actually. So what we're saying is, for a unit increase in ad revenue, so if my ad revenue increases, our ad budget increases by $1, right? The money spent on ads increases by $1. My sales, would it be positively impacted or negatively impacted? The way I would interpret it is, because this is 10 and this is positive 10, it would be positively impacted. Hence, if my ad budget goes up by $1, then my sales would also go up by $10. 10 units, whatever, $10 or 10 units, whatever, positively dependent. So if my ads go up by $1, my sales goes up by $10. Why did I say 10? Because the 10 is mentioned here. Correct? So you don't have to mention to the business about this particular equation. You don't have to talk about this equation. That's okay. I mean, if they want to look at, if they want to talk about the equation, if they're interested in the equation, that's a different story. I think the way you'd want to tell it to someone who doesn't understand data science is, historically we have analyzed um, data related to money spent on ads, the number of competitors in a given region, and the number of stores in a given region, and we were able to mathematically model how the sales are associated, or how the sales are dependent on these three features. A few key insights are, first one, as the ads increase, or rather as the number of ads increase, by if the ads revenue or ads budget increases by $1, that means the money spent on ads, if it goes up by $1, then my sales go up by $10. If the number of stores increases by one unit, then my sales increases by $6, or 6 units, whatever those units are. And if the number of competitor increase, if one additional competitor is added in that particular group, then in that particular region, then our sales drops by 5 units. So this is essentially the kind of explanation that you'd like to give to someone who doesn't understand data science. You don't have to explain him that equation. You just have to explain how sales is related to ads, or how sales is related to competitors, and how sales is related to your uh, your number of stores. So that's how you explain it to someone who doesn't understand data science. So this is just an example of how you can explain it to data science. You can also do the same for, let's say, a decision tree algorithm, or let's say any other algorithm also, for that matter. Okay, cool. Let me take a few questions. How to explain? Okay, what about performance and scrutiny? What do you mean by scrutiny? Badrinath, I'm sorry, I don't understand what security. Okay, sorry. Performance and security. Yeah, it is important, super important actually. Security is one of the most important elements around data science as well. So security is key, but would questions based on security be asked in an interview? And at this particular point, not as many. Not a lot of security-based questions are asked at this particular point. Performance also is a non-functional requirement. It is not something that is related to data science, so to say. It is basically how you can make sure that your algorithm is built well or faster. So you may have such discussions, but I think questions could be around, okay, if you have used a random forest algorithm, and let's say you've used the linear regression algorithm, which of these two is a faster one? Is random forest faster, or is linear regression faster? So we know for a fact that linear regression is faster than random forest. So in certain cases, I might want to use certain models as opposed to another, because certain models are much faster to build and faster to evaluate than other models. Such questions would specifically come up whenever you're dealing with large volumes of data. Right? Yeah. So what is the frequency of questions around that? You can expect questions around it, but I think those questions are primarily focused to people who are slightly experienced. So if you're already experienced in the IT sector, and if you have knowledge about APIs and scaling up APIs and things like that, that's where those questions really come in. I personally don't think we should fret too much about. I don't think we should personally fret too much about security and things like that at this particular time while we are preparing for our interviews. We can. I mean, if you're asked about it, it's okay, but I don't think that's a major section to be worried about at this point. Are we expected to know the basics of stats and probability? Absolutely, yes. I mean, probability. You should be able to understand probability. Statistics, basically, because let's say, for example, you've built a linear regression model, and how do you evaluate if a particular feature is important or not? What is the null hypothesis of a linear regression equation? You could be asked questions around this, right? The null hypothesis of a linear regression is that all the features are independent from, or your target variable is independent of your input features. So yeah, basic statistics of what is a t-test, what is a chi-square test, when do you apply a chi-square test. When I have two categorical variables, if I want to understand a different dependence between the two of them, we apply chi-square test of independence. Great. When do you apply ANOVA? If I have multiple groups and I'd like to analyze if each group behaves differently with each other, then we would perform ANOVA. Right? That's when we do ANOVA. So yeah, stats is something that uh, that is critical, that is useful and important for us to understand as well. So yeah, but will you be directly asked questions on statistics? At times, yes. At times, certain companies do ask you questions on statistics. Certain interviewers are very specific about your understanding around statistics. So yes, you could be asked questions around that as well. Yeah. So again, it solely is dependent on what kind of work you're doing. Let's say you're doing something that is very specific around your problem. One of the things that you have mentioned in your interview is, let's say I have performed feature removal based on p-values. Then you have shot yourself in the foot by mentioning that, because now you're going to get a question, what is a p-value? And the moment they ask you what a p-value is, that will eventually route your questions into what is a t-test and why do you perform a t-test and things like that. So it'll land into um, towards statistics eventually. Yeah. So yeah, it is important that you learn your statistics well. We don't have big data included in our course, so what is that we need to know about big data? See, you don't need to understand, you don't need to learn big data, right? When I say big data, what I mean is how is big data different from data science? You just have to understand that. In which scenarios do you have to understand? In which scenarios do you move towards big data? When do you move towards big data? When do you and how is data science different from big data? I think these are the questions that you have to answer. There's a very common misunderstanding between people when they say that, okay, people often use the term big data and data science quite interchangeably. So it's important first that you understand what is the difference between big data and data science. Secondly, um, when you have a big data problem, how do you solve it? How do you solve a big data problem, or how do you solve a data science problem on big data? So that's where you will be using your tool like PySpark. So you don't have to learn Hadoop, you don't have to become a master of big data. No, just understand that, okay, when I have a large volume of data, my machine is not going to be able to feed that much RAM to that particular data set. So for example, my system has 32 GB of memory at this point. If suddenly, let's say, for whatever may be the reason, I have a data set which is, let's say, 100 GB of data with me, how do I solve a problem with that? I cannot load that data set in my machine itself. So how do I solve such problems? In such cases, the same solutions can be used, but instead of same models can be built, but instead of building it on Python, we will be building it on PySpark, a big data platform. PySpark is a big data platform. So you need to know when to move from your regular models to from your regular machine from your regular Python to PySpark and things like that. Yeah. So that's the level of depth you're expected to know in terms of big data. You don't need to know, you don't need to be able to code Hadoop and things like that. You don't need to worry about that, Shruti. So hope that answers your question. What is the depth of AI required? See, AI in the sense deep learning, I'm assuming that's what you mean by AI. It depends on the role that you're applying for. If the company, and again, that's the reason why I say it's important that you understand what role you're applying for. If you're applying for a company that is already doing work on deep learning, then they would expect you to have knowledge on deep learning. If the company is not particular about your deep learning experience, if the company is not particular about, they're more concentrated on machine learning and let's say data science, simpler data science problems, or the role is not very heavy in terms of deep learning, then in that case, you don't have to have that experience. But I think most of the roles that we see outside today, require you to have deep learning experience. When I say experience, at least some level of exposure in terms of either solving a regular deep learning problem on regular deep learning problem using a TensorFlow like platform and things like that. So at least a level 100 experience in deep learning is expected by most profiles these days. So yeah, that's as far as again, I'm going to go back to the same point that I mentioned here at the beginning, right? From a skill set standpoint, this is it, right? So this is what you need to know. You should be able to learn one of these two. That means either Python or R. At this point, I know that we are all learning Python, so which is great. SQL, I don't know if you all are familiar with SQL. If you're not, learn SQL. And these two, PySpark and TensorFlow or PyTorch. The reason why I need this is because basically for your deep learning experience, for deep learning and stuff like that, you need to learn these two. This is your big data. This basically ticks off the big data bucket. So most data science profiles expect you to have these four with you. You have to be really, really strong there. Because that's your primary, that's the root of your skill set. And I don't think learning SQL is very difficult. And if you learn data science, then you should be able to learn deep learning, basics of deep learning. I don't want you to master it before you apply for jobs. So yeah, this is, I mean, I would still call it optional, guys. I mean, it's not mandatory for you to know it. It's optional. Let me put it that way, because not everybody will have to work on a big data platform. So it's at least know theoretically what is big data and when do you need to switch to PySpark. Just know when Python is not going to be enough to solve problems. When my data set is very large, I'll have to move away from Python to PySpark. Know that and just understand about big data. So I'm not going to call understanding around big data and PySpark mandatory, but most data science profiles are expecting you to have 1, 2, and 4 for sure these days. Okay, more than PyTorch. I think PyTorch is more relevant, but I think TensorFlow and Keras, that's what people are looking for currently. PyTorch is more modern, so if you learn model, then that'll be great. Any Python programming questions? As I said, see, nobody asks you questions around Python programming during the interview. The Python programming questions are specifically going to be in the hands-on session. You will be having a hands-on session, and in that hands-on session, you'll more or less be asked questions on it. So most of the companies have a hands-on session these days. If they don't, they might ask you questions about, they might ask you, most companies actually have a hands-on session. If they don't, then they might simply ask you questions around, okay, what is the library that you use for, that you use in Python for deep learning, and things like that. So some very preliminary questions. It's very hard to ask questions in an interview on programming, right? So yeah. How to prepare for hands-on? Are we expected to know how to build UI in Python? No, you're not. This is a data science interview. In a data science interview, see, Python can be used to do numerous things, 100 different things. You can use Python to design games. You can build predictive models on Python. You can build an end-to-end application on Python. You can use Python to do so many different things. We are not interested in all of that. No, as a data scientist, you're not expected to build UIs and stuff like that. Your knowledge on Python, see, understand this. Okay, when we talk about Python, right, there are something, the way Python operates, right, there are some basics of Python, right. The basics of Python basically include data structures, right, and like any programming language, your data structures, your control flows like your for loop and things like that, right. So for example, your for loops, let me just mention it as loops and control flows, right, and things like that. So these are basics of Python, Right? Any Python programmer should be able to work with, let's say, dictionaries, lists, tuples, and things like that. And everybody should be able to write a simple for loop and if else construct and so on. Based on this, there are many other concepts that are, many other applications that can be, that Python can be used for. Like, let's say, web development, game development, right? You can build a UI, and then you can perform data science, and then you can use the same for doing some blockchain work, for web scraping. So numerous scenarios Python can be used for. As a Python, because we are learning Python for data science, you are expected to know this and this. So you don't need to know any of the others. These are not for us. And the rest are not for us, right? So those are for people who are going to use those. We are not going to do any of those. Under data science, what do we have? Under data science, we have NumPy, SciPy, Pandas, Scikit-learn. These are the most popular data science libraries, data science related libraries. So you should know these and you should know these for your interview. So if you are able to do the first and the second, then you should be able to, or if you have worked fairly well in your on these two concepts, then you should be able to attend your data science interview well, or at least your data science hands-on session well. Okay. Okay, so hope that answers your question. Should we be very good at Python programming? We have been trained as much as we need in data science. Yeah, I hope that answers your question, Sumelia. That's all that you need to know. You don't need to know anything beyond that. Whatever is required for data science, that's all that you need to know. You don't need to know anything beyond that. That's the level of Python expertise that anybody would be looking at. Okay, cool. Cool. So let's move on. Let's move on to the next part. So tricks of the trade. So this is what I was talking about. So there are numerous questions that you would be asked specifically based on the work that you're doing. The next type of questions, right, that you could generally be asked, as I mentioned, is your case study based questions. The case study based questions could basically be like these. Case study questions could be like, the interviewer would give you a particular scenario and you're expected to solve this particular problem. I don't want you all to answer the question. I'm going to give you a scenario and just think about it. I'll give you all a few minutes, just think about it. And then I will give you one possible way of solving this problem. And then you can evaluate if that is a good approach or not. Because if everybody is going to dump in approaches, then we might not be able to progress in the class. So think about a possible way to solve this particular problem. So the question goes this way. So imagine you are let's say you're Facebook, right? Let's say you're working for Facebook and as a team lead, and in your team you have a few openings. Okay, there are a few openings in your particular team, and you'd like to hire a few people, right? And because you're Facebook, one of the most popular companies outside, obviously you would receive a lot of applications, right? Let's say you've received 10,000 applications for the two roles that are open as data science. Let's say these are data science roles only, just for the simplicity's sake. So you have a team, and within your team you have two openings, or let's say one opening for that matter, and you'd want to fill that particular role. You have received a lot of applications for that particular role. Now, the thing about this particular role is that you would want to make sure that this particular role, or the person who is going to be hired in that role, is similar to the ones that are already there in the team. Let's say your team already has 20 people. You would want to make sure that the new person who will get hired is very, very similar to the existing 20 people in your team. Okay. Question is, how do you identify Of course, you cannot interview 10,000 people. I mean, if you interview 10,000 people, you're going to die. I mean, there's no way you want to do it. So you are expected to build an algorithm, because again, you're a data science team lead. You're expected to build an algorithm that can automatically identify the best person, or the most eligible people out of the 10,000, or the 5 most eligible people out of the 10,000 people, so that you can go ahead and interview them. Okay, that's the question. I'll repeat myself again. There are 10,000 people who have applied for a particular role in your company. You'd want to fill that particular role if and only in such a way that that person who's going to get hired out of the 10,000 is very similar to the ones who are there in your group already, who are available in your group of in your company already, in your team already, let's say. So the question is, how do you hire this person? There's no way you can interview, because if you're interviewing, then you'll have to interview 10,000 people. So if you're going to interview each of the 10,000, then you'll never be able to hire that person. So your responsibility is to devise an algorithm to automatically shrink the size of people you'd want to interview. I'd want to identify 5 most frequent, 5 similar people. Imagine I have my data like this, right? Let's say there are a lot of data. So this is my team, and I have 20 people in this team, and I have opening for 1 person, right? I have one opening. For this particular team, I have a lot of information about my existing team. So I have information about location, where they come from, skill set. I have information about their experience, right? Their likes, their dislikes, and things like that. Because the reason why I want to hire a similar person is because I want him to be a perfect fit in the team. I don't want this fellow to be an alien in the team. So that's the reason I want to make sure this fellow is a perfect cultural fit within the team. Okay, so I've captured all of this information: location of the person, the skill of the person, previous experience of that particular person, his likes, his dislikes, and so on and so forth. Similarly, for the 10,000 applicants that I have the same exact information with me, right? The same exact information I've captured. So location, skill set, experience, likes and dislikes, right? Location, skill, experience, likes and dislikes. Same information is available on both sides. Question is, how do you identify out of the 10K those 5 people who are going to be interviewed for this particular role? Think about it. Not in a hurry, unless you are, but I'll give you like a couple of minutes. Think about it. Think about how you're going to solve it. Yeah, and of course, this is a data science interview, so think of data science approaches to solve this problem. Right. So use data science techniques. Think of what kind of data science techniques can you use to solve this particular problem. Filter on experience required and skill sets. Yeah, I mean, I have 20 people within my team, so I want to find someone who's similar. I just don't want to filter someone on skill set and experience. I have likes, I have dislikes, I have location, I have, let's say, a lot of other information as well. It's not just on list on this. Since it's categorical data, we go for classification problems since we have historical data to compare. What is categorical data? Where is my target variable here? Think of, okay, here are a few questions. Where is my target variable? Do I have a target variable? Regression model. What is my target variable here? Why is years of experience a target variable? Okay, think about it. I mean, you're not in a hurry. Think about it. So firstly, think of, do I have a target variable? Is this a classification problem, or is this a supervised or an unsupervised learning problem? If it is supervised, then is it classification or regression? take all the liberty that you want and devise a possible solution. Grouping and narrowing down to the data set. Okay. Appropriate person. Build a regression model. Okay. I can use a decision tree and use the below information, skill set, experience, and okay. But decision tree with what? Mean of the aspects of the team and using K nearest standard. Okay. Linear regression model. Interesting thought, Yogendra. Interesting thought again. SVM. Okay. I'll give you all another minute. Think about it. Confusion matrix is not used for building a model. Confusion matrix is used for evaluating a model. Confusion matrix is built after you build a model, how well the model is built. So I'm afraid, Sham, that is definitely not the correct answer. Confusion matrix is wrong. I think there's a gap in the understanding of what a confusion matrix is. It's worth going back and reading a little about what confusion matrix is, Sham. Okay, so let's answer this question. Okay, so firstly, and by the way, this was a question that was asked to me in one of my earlier interviews. Trust me. So this is a real world problem that was, or a real interview question, so to say. This was asked, actually a similar problem was asked in 2 interviews of me. A similar problem, not the exact problem, a similar problem. Okay, let's answer this question. The first question is, first things first, the most obvious question is this a supervised learning problem or an unsupervised learning problem? This is a unsupervised learning problem. The reason is, I do not have any historical information about who was previously interviewed and if they got hired or rejected. I only have historical information on who got hired, because I know that those 20 people are there in my team. I know information about who got hired. That's all. I have no information whatsoever about who previously got interviewed and who have been rejected and who have been hired. Out of that, I only have partial information, which is I know the existing people in my team. So do I have a target variable here? Do I know what I'm chasing here? Unfortunately, no. I know that I want 2 people. I know that I want 5 people, let's say. But I don't have a target variable in my historical data that I can solve a problem for. I hope that everybody understands what that is. I hope everybody is clear with it. Right? I don't have a clear-cut target variable over here which says yes or no, hired, not hired. Do I have a historical data which says 10,000 applications or 20,000 applications historically? Out of the 20,000, 20 people got selected. The 99,980 people got rejected. Do I have a data set like that? In this problem statement, I don't. I just have 20 people who have been hired. I just have information about who have been hired. I have information about 10K applications which have come in for the remaining 5 people. So that's all that I have. Okay. So unfortunately, this cannot be solved by a supervised learning problem. I can solve it by a supervised learning problem if I make an assumption. And the assumption is, if I assume that there is a data set that is available historically, which tells me to hire these 20 people who are there in my team, how many have been hired and how many have been rejected? How many have been interviewed and how many have been rejected? If I have that information, if I assume that information is there, then I can solve this as a classification problem. Does that make sense? I hope we all understand that. So let's make that assumption. Let's solve this problem in both ways. Why reject one approach? Let's go and solve this as both problems. Okay, so let's make the assumption. The first assumption is, just a second. The first assumption is that there is a data set that is available. A data set is available which basically has information about, right? Let's say people who have been rejected. This is the list of interviewees. This is the list of people who have been interviewed and hired. I have a column which has this, right? Basically hired is these 20 people only, because these 20 people who are there, hired means those are the 20 people that I have. If I have this kind of a data set, and if I have one column which says rejected or hired, I can build, so I have one column which says rejected or hired. Now tell me, is this a classification problem or a regression problem? My target variable, is it categorical or numeric here in this particular case? Anyone? I'm looking at the chat box hoping that somebody would ping. Okay, classification, categorical, very nice. Yeah, super. So because my target variable is now categorical, this becomes a classification problem. Very nice. So because this is a classification problem, I can go ahead and simply solve this as a classification problem. Great. If let's say this, and I can build a classification algorithm, I can take this new data that is available of 10K, run it through the classification model. Let's say I can use logistic regression model or decision tree classifier or random forest classifier or any of the classifiers. I can pass this new data set through it and I can predict who is likely to be hired. Out of this, identify the people who are likely to be hired and interview those people. Make sense? Yeah, that's essentially one way of solving this problem. You can solve this as a supervised learning problem. That is if I assume that a data set is available for me which looks like this, which gives me information about who has been hired and who have been rejected. On the other hand, we can also solve this problem in a slightly different way. We can solve this problem as an unsupervised learning problem. How do you solve it as an unsupervised learning problem? The way you can solve this as an unsupervised learning problem is if assuming that you do not have this data, let's assume that you don't have this data available with you. All that you have is you have the information of these 20 people and you have the 10,000 people with you, 10,000 applications that you have, and both are similar data sets. So what you do is for the 20 people data set, this is 20 people, 20 people data set, right? Keep this data as is, right? For the remaining remaining 10,000, right? For the remaining 10,000, for the 20K, you compute a mean observation, or let's forget about that for a second. Let's not worry too much about the mean. So I have the 2020 records data, which is my current data set. For the 10,000 data set, you perform clustering on this. When you perform clustering, you're going to create groups. You'll create small groups. Now identify which of these groups is closest to the existing data points by using a nearest neighbor model, compute distance. You can compute the nearest neighbor distance, the Euclidean distance or whatever distance, and you can measure which of these groups is closest to my existing 20 data points. Out of these, select whichever one you're interested in. Let's say group 5 is the closest to these 20 data points. And if group 5 is closest to the 20 data point, then use group 5 and interview everybody in group 5. If group 1 is the closest, then use group 1 and interview people on group 1, and so on and so forth. So that's another way of solving the same problem in an unsupervised approach. This is supervised and this is unsupervised. Two different approaches to solving the same problem. Okay, these are the kind of questions that you would be asked. There would be a scenario thrown at you and you're expected to answer that particular scenario however you want. So this is what is referred to as designing a particular experiment, designing a particular solution, a data science solution. So you could be asked questions like these. I'll just repeat the unsupervised learning approach just for the benefit of everyone. So you have 20 people. So for the 20 people, I'll simplify it. So for the 20 people, you compute a mean observation. Then you can convert this whole thing into numeric data set. You compute mean experience, right? Mean skill set in Python, mean skill set in mean years of experience, or mean years of skill set in, let's say, Python or whatever. You compute a mean observation, an average observation of this particular data set, a centroid. Think of it as a centroid. You compute the centroid of those of your 20 data points. Similarly, perform clustering here on the right hand side. Out of these, when you perform k-means clustering, you're going to get, let's say you've identified k clusters. You will find k centroids. Out of the k centroids, find which of these k centroids is closest to the centroid on the left hand side. The closest centroid or the closest cluster is what you will use to perform further interview process, or you will take that up for the further interview, because the closest cluster is what is similar to that of your 20 existing data points. Yeah. That's another way of solving the same problem. Hope that answers your question, Manohar. Okay. Cool. Moving on. So these are the kind of problems that are generally asked in the case study section of your interview. While these are a few, so I'm going to take 10 more minutes before I open up for other questions. For any other specific questions, I'm going to take 10 more minutes. The next part is about and I think this is an important section as well. While the interviewer has all the right in the world to ask you questions, you also have good amount of questions that you'd want to ask your interviewer about. And I think the questions that you need to ask your interview are, especially on the data science side, are super critical. And I'm going to talk about that a little. The first is check about the team that you're getting into. Is it a new team or a matured team? Is there enough people? So because all of you are new, so if you are getting hired into a data science team where you're expected to lead, the complete team, or you are the only one in the team, then it might be slightly tricky for you to navigate yourself through it. So just look for enough guidance. So if you have somebody to guide you through the whole process, so if it's a slightly larger team, then there's enough. Then you'll have enough time to prepare yourself before you launch, or you'll have enough time to ramp up before you actually get completely onboarded onto the or you'll have enough people who would have solved problems already, so they'll help you guide yourself through and navigate yourself through. Secondly, what it tells you is if it's an existing team, then things are slightly more streamlined. You're not going to be given random work for data entry and things like that. So you'll be given proper data science work. A new team means you are basically like a hero for them. So everybody would give you all kinds of problems, and you're expected to solve every possible problem under the roof. Becomes slightly difficult. The third thing is, if it is an existing team, that means the manager already understands what data science is, which makes your life easier, because if the manager understands what data science is, if the lead understands what data science is, then they're not going to give you weird problem statements where neither you have data, and they're not going to give you they're not going to give you data sets and say build a model by end of the day. So they will understand the difficulties of a data scientist. So it is really important for you to know this, because in a lot of companies, a lot of data science managers are people who are not data scientists. They are people who are probably moved in from a non-technical background, or let's say people who are non-data science background into data science. And the reason that happens is because you got to fill roles, and the way you fill those roles in large organization is by moving people from within the organization. And at times you may have a manager who doesn't understand what data science is, and who's expecting you to solve data science problems. So there are scenarios where something like this could happen. So be aware, understand, know about the team, right? Know about what your manager has done. Do your due diligence in terms of if your manager knows enough data science or not, right? That's the first thing. Second thing is availability of data, meaning data is like oxygen for us. For a data scientist, if you don't give him data and ask him to build a model, what would you do? It's as simple as tying down two legs of a dancer and asking him to dance. I mean, you can dance with the hand, but you know how it will look like, right? So you cannot do this to a data scientist. You cannot not provide data to a data scientist and ask him to work on it. So one of the questions that you might want to ask and want to verify is, do you have access to the data? At times, the reason why this is important is because certain companies, what they do is, they tell you that the data is confidential, especially banking and telecom companies. They tell you the data is really confidential and they cannot give you access to data. They'll give you some sample data and ask you to build models on it. Um, and you know that when you build models on sample data, models that you build may not be really great. So that could be quite challenging in itself. So availability of data could be at times slightly tricky. The third is, if you're working in a consulting company, you might want to check if you will have the ability to talk to clients, actually have discussions with the clients, meaning that in a consulting company, there's a lot of loss of information, or transmission loss, as you can call it, because I don't know if you know of the game called Chinese Whisper, where a word is whispered in somebody's ear, and by the time it reaches the end of the classroom, the word completely changes its meaning. So what I mean to say is, especially when you're in the consulting environment, when you're in services environment, it is really important for a data scientist to be in the field and talk to the business stakeholders directly. It's not something that is, I mean, this opportunity is not something that is provided to freshers that often. I understand that. Freshers may not get the opportunity to directly talk to customers straight away, but being in an environment which directly operates with the customer is very, very useful. So you would want to be as close as possible to the environment, you'd want to be as close as possible to the business. You'd want to be as close as possible to um, um, not only the business, I mean, to the client themselves. If you are not given the opportunity, that's okay. At least if the team has the opportunity in general to interact with the client frequently, then that means there is a healthy conversation that is happening. That's something which is really important. So it's good to have that particular clarity for you. Third is, check if your skills align. Check if the work aligns with your skills. That means, again, as I said, data scientists can have many subfields, right? Many subsections, meaning data scientists, data science in, let's say, a specific domain, data science in healthcare, data science in blah blah, and so on and so forth. So data scientists whose expertise is primarily into natural language processing, data scientists whose primary expertise is into image mining, data scientists whose primary expertise into statistics and things like that. So you have specifics at times, or at times work might demand a specific skill set from you. Like, for example, you're expected to work on only unstructured data. At times, you might be expected to work on small volumes of data because you're probably working on clinical trials data and things like that. So, see if your interest and if it aligns with the work, or if your skills align with the work or not. It is really important to check that, because there is a chance that people might misalign themselves to this, and you might not like the work that you do after you get into the org. But trust me, I would not suggest you to be so picky at the early stages of your career. At this point, I know half of you are like, any data science job is good job at this time. Absolutely agreed with you. I think at this point, any data science job is a good job. But in general, I think it's important that you know what kind of a data science role you'd want to get into, rather than cursing yourself for getting into that particular role.